taking this with me again.
Yeah, it's great. So thanks a lot.
You're welcome. See you.
What is your nickname on your site?
I'm Voucher. Just a first name.
Okay.
See you later.
Thanks a lot.
Is it possible that I can use power?
What do you want to use?
Power.
I don't know. Yeah, sorry.
Okay, thanks. Let's go back.
This one?
No, it's on.
No, it's on blah 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 blah. Blah 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 blah. Yeah?
Okay, good.
Okay. Babbling into different speakers.
Okay, thank you everybody. It looks like we're going to fill up again this talk, so if there are any seats in the middle, can you please defragment now to make space in the aisle for people coming in? Because we really do have to. How's that? So I see seats here. I see the
Okay, we're fine. I'll reach you. Thank you.
Yes? Excellent. Thanks so much.
So especially, excuse me, back row. Can you move over towards the camera, please? Okay, our next speaker, always popular. Bert Vermeulen is going to talk about switchdev, which is essentially a software environment for white box switches. Is that correct?
No. That was last year.
That was last year, okay. So
This is the kernel subsystem.
the kernel subsystem. Okay, switchdev. Bert, take it away.
Hey, good morning. So I'm here to talk about switchdev. First, a little bit of history to set it up. So what's an Ethernet switch, basically? Initially, an Ethernet switch was no more than what was called a bridge, something to forward Ethernet frames between basically two wires. You can't just connect two wires together, so you had something called a bridge, which was initially useful for like a repeater, stuff like that, to stretch the length of an Ethernet run. But of course, that was very limited. You can only connect two lines to a bridge, so therefore multi-port bridges started coming in quite soon. We're talking about like 34 years ago, by the way. So a multi-port bridge, formerly known as a hub. You get a packet in on one port, and it just floods it out to all the other ports. So hubs became very unpopular very fast because obviously they tended to just generate a lot of traffic where it didn't need to go. So in came switches. What are switches? Formerly, as different to hubs. Essentially, they have an FDB, a forwarding database. It does learning and aging of MACs. Right? That means it sees a packet come in on one port, an Ethernet packet, a frame, sorry. It remembers that the source MAC address came in on that port, and therefore if it ever gets a frame destined for that MAC address, it'll send it out to that port. Yeah? It'll do that by storing that entry in the FDB. Just MAC address port. That's the essentials of it. That's the least of an FDB. Aging is an important part of that. We keep a timer, and if it hasn't seen a packet from, is it 5 minutes? Or? Okay. You said like 5 minutes left. Jesus God, what have I done? Good. No, so if you see a packet come in, okay, you know that it belongs there from on that port. but if it hasn't generated any traffic, you should age it out, because maybe that host has moved to a different port, different segment of the network, and therefore you should start flooding it again out of all the ports. So then what came in afterwards was VLANs. Very important. It's a way to segment your switches. Lots of ways to do VLANs, but you can do the VLAN priority tagging as codified in 802.1q, the standard. Or you can just do a partition switch where you don't have any extra tags on your Ethernet frames, but basically you configure your switch to be like 2 different switches, 3 different switches. And if you want to forward traffic between those partitions, you actually have to connect a wire. So that's the basics of an Ethernet switch, right? Now, we've been able to do an Ethernet switch, or an emulation of it, you might say, in the kernel for a long time. But that was, of course, a software thing. You use a bunch of NICs, basically. You put a bunch of cards. You put like 4 or whatever cards in your server, and you can configure a bridge, a software bridge. And it's got an FTB all implemented in the kernel, and you can, it'll forward frames between them, things like that, and route them out to IP interfaces, things like that, as needed. But of course, there are some limitations there. Very good. First off, everything is done by CPU. So you need the actual general purpose CPU to do a bunch of comparing of frames, frame MAC addresses, looking up in the FTB, and it's not super efficient. Switches tend to be a lot more specialized. They have specialized memory typically for implementing an FTB. That just makes it faster to do lookups. Another thing, of course, is these things tend to be I/O bound. Initially, in early Linux, getting a frame on a NIC meant getting an interrupt on your CPU. The interrupt would then cause the kernel to receive the frame from the NIC, but of course, too many interrupts kind of ruins your performance anyway. That was solved a long time ago. I forget what that's called. What was that system called? Sorry? NEPI, that's it. That basically just handling more than 1 frame per interrupt. But of course, you've still got the same problem. As long as the kernel is doing all this manual work on a general purpose CPU, it's not going to be super performant, right? So then something interesting started happening. Little server routers and switches started coming out. Starting with the venerable WRT54G, and of course the Open WRT project came in. Now these are really kind of very specialized. They're small CPUs, but they have a built-in switch chip. That means that they have typically something like 5 Ethernet ports, and you can configure those switch chips to actually do the switching between them. In other words, you program their FTB. You program the switch's FTB, so that if it gets a frame from one port, it could actually know, oh, I'll just switch it through. I don't need to send that to the CPU. Of course, much more interesting, particularly on those little server routers where the CPU really isn't that strong. It could really, you can't really do CPU switching on those, right? So the OpenWRT project needed a way to configure those switch chips in there. The problem, of course, was that you can't just use the vendor software, vendor-provided software or source code to program those chips, because it's oh, sorry. looks like. Okay, the problem is that those vendor software tended to be quite hacky. A lot of it was done in user space. All right, that's one thing, but a lot of it was very much a hack, programming a switch chip via some random SPI port or I2C port, nothing standardized about it at all, and that was a real problem. What the OpenWRT folks found themselves doing was having to do really wildly different things to get the switch chips in different platforms. So they came up with an abstraction, a switch configuration setup called swconfig. And it's a kernel framework and some user space tools to abstract out the programming of switch chips. And it really got them ahead because there wasn't anything like that in the kernel at the time, the mainline kernel. So it was a big win for them. The features they needed to support tended to be kind of wild. I'm not sure what all was in there, but it was just random stuff that's supported by vendor Ethernet switch chips. Some weird features sometimes. I'm not sure if swconfig really supports them all, but The problem with that was that swconfig was never upstreamed to the mainline kernel. I'm not entirely sure if the OpenWRT product tried to upstream it was refused, or if they didn't bother. Maybe somebody here knows if somebody's on the OpenWRT? No? They didn't show up?
Yes, it was twice, that's pretty good, but then there was this ESA thing.
That's next slide. I'm coming. Yeah.
And that one was more or less rejected, or lots of developers.
Right. So it was somewhat tried. Oh, sorry. Hauke, is it? Says that it was tried to submit upstream to the mainline kernel, but it was more or less refused because there was the kernel was starting to get something similar, and that was the DSA subsystem. The DSA subsystem stands for distributed switch architecture, as I recall. It really kind of comes from a feature present in Marvell Soho switch chips, the MV88E series chips, which I think were originally the Intel switch chip division. I think Marvell just bought it. It was initially just for the way the Marvell chips work, but actually it was pretty generic. You could do lots of other things with it. Some Broadcom and some Broadcom drivers were submitted for B53 series and the Starfighter 2, which I have no idea what it is, but apparently it's one of these small switch chips that you found in Soho routers. I see there's a Qualcomm Atheros switch supported as well, the 8553, I believe, the 8000 series anyway. So there's lots of room there, but the DSA subsystem, and this is very, very new, it exposes all the ports that it has access to the kernel. That means if you have a server router running a mainline kernel with a DSA-supported switch chip in it, and it has, say, 5 Ethernet ports. That means you get ETH0, ETH1, 2, 3, 4, right? So you get actual 5 ports. You can put different IP addresses on them, and just use them as a router. That way you can bridge them together as you like. And if you bridge them together, the magic that happens there is it offloads the actual bridging to the hardware, and that's really important, right? Of course, that's what swconfig also did, but this is like, it works in the kernel, it works in the kernel but towards user space, exposing the ports, but it does the actual switching, if you configure it that way, in hardware. So that's really important. And the cool thing is, the way you normally configure bridging with BR control or the bridge tool or whatever, you just do it as usual with your interfaces as if there were NICs in your system, and just behind the scenes, the actual switching happens in hardware. That's really important, right? But the problem with DSA is that it was intended to be MDIO only. I think that's because of the original Marvell thing, I don't know. But it was kind of limited in that way. There's lots of other ways to connect Ethernet switches to your system, as many as there are buses, right? And there's enough buses. So then the switchdev system came in. The switchdev system is a proper kernel subsystem. That means that you can invoke it from any bus. For example, you can have a switchdev driver that is triggered by a device being present on a PCI bus or PCI Express bus. That makes it, of course, more interesting to the higher end type of switch chips that need the kind of bandwidth that PCI Express uses. It's a very generic system, right? It's more generic than DSA. That means that DSA was essentially changed, the DSA subsystem was essentially changed in the kernel to be a switchdev driver, right? So DSA is still there. There are still DSA drivers, but DSA, the framework itself, is essentially a switchdev driver. If you want to do support, switching support for an MDIO supported switch, an MDIO connected switch, sorry, in the kernel right now, what you would do is you'd write a DSA driver, right? Because that's kind of, it's kind of the MDIO part of switchdev. You might see it that way right now. It's kind of the easiest way, right? But switchdev in general is super generic. It's got standard operations to work on your FDB. So add entries, age entries, set aging time, and various other parameters. MDB as well, support, so multicast caching, group caching, and things like that. VLANs as well, setting up VLANs. That's switchdev. Sorry. And the big news, and this happened last year, is that it was a while after switchdev got merged before anything but DSA was supported. But at some point last year, Mellanox, a vendor of very high-end switch chips, submitted drivers for their Switch X2 and then their Spectrum switch chips. These are super, super high-end, right? The Spectrum has a forwarding rate of 6.4 terabit per second. To give you some idea, that's basically, you can have a 32-port switch, every port 100 gigabit, doing full duplex on every port constantly, and this thing can handle it, right? You can use a switch with the Spectrum chip in it, or the Switch X2 chip in it, right now, running a mainline kernel, doing 100 gig on every port, 100 gigabit on every port. Just on a mainline kernel, standard driver, using the standard tools, IP route 2, bridge, all that stuff. That's magic, right? So what Mellanox did is very much a pioneering thing. I think pretty much everybody in the NetDev community, in the kernel, is hoping that other vendors will follow. It'd be nice if Broadcom would follow. Take a small miracle, but it might happen. In any case, there are a bunch of other vendors that are sort of on the fence about this. You might say somewhere in the spectrum between Mellanox and Broadcom. There are a lot of other ones. Cavium seems kind of interesting. So we'll have to see what happens. Hopefully, some more vendors will come in and write drivers. If you want to take a look at the switchdev subsystem, look at the kernel source. Include net switchdev.h. That's the entire API. It's super simple because it's just so generic. I encourage you to take a look at it. So that's all I got. Any questions?
6.4, so it was for one node. Can you detail a little bit this number of 6.4 terabytes per second?
But, sorry, what do you mean?
6.4, the number you said.
Yes.
It was in which context with
Oh, no, that's just the total switching capacity of the Spectrum chip. The Mellanox Spectrum chip is 6.4 terabit. I don't work for Mellanox or anything. I don't mean to, but I'm just saying that's a really high-end chip. It has a total switching capacity of 6.4 terabit. I don't know. That's just, okay, that's their marketing literature. I assume it's correct. I'm naive. I don't know. So, any other questions? There's an exam after this, so if you don't have questions. Okay, thank you. I think it is low battery. Yes. No. Isn't it? Or maybe. Or maybe it's just, if it's blinking, it's low battery. Yeah, I think it's right.
Speaker? I am. For my sins, Ray Kinsel. Sorry? Ray Kinsel. I did work on switching in the past. And we were starting to do something. I worked for Intel, so we were starting to do something that looked like switchdev for the Fulcrum stuff.
Okay, cool.
But it got...
So Ray, you're using your own laptop, right?
if I'm allowed, yeah. I have it on, what you call it, USB key, if that helps as well.
No, it's all right.
Hello?
So I don't know if ThinkPad is going to work on it. That's a joke.
Yeah, no, this is the Yoga. They will pry my ThinkPad out of my cold hand. No, I looked up your LinkedIn profile. I was stalking, and I saw you went to DCU, so I kind of assumed.
That was my postgrad. I was in UCG before that.
Oh, were you?
Yeah.
You know what they say about assumptions? Make an ass out of you and me.
Okay, so where am I?
This is nice. You see this? Laser cut box.
They're homemade hardware. They built their own hardware out of, I think it's a Raspberry Pi inside.
It's brilliant. I've got a little cost down below there. It's brilliant. You know, it's not picking it up.
Are you mic'd up?
I know, but it's not picking up my. It's not extending the display.
Okay, well it worked for me.
I don't know why. Very
You
strange.
want to do it on mine with a USB key.
Yeah, maybe that would be better. Oh, just with the, it's okay.
2 weeks ago, I was explaining all the things of the stack to this guy doing 3 hours No, they are selling guys.
A bit strange, isn't it? Ta-da! I don't know. It was a funny one. I exported it as PDF, so
Exported from.
PowerPoint.
Why don't we use PowerPoint?
Oh, okay, that'd be perfect. Yeah, PowerPoint?
No, I hope not.
Okay, it's on the USB key. 53 meg volume. Yeah. Maybe PDF. Perfect.
And you are using this floor, it's a standalone
So next up is Ray Kinsella. I am again going to ask people, please, we can't have anybody in the stairwell, so if there are spare seats to the inside of you, please move in so that we get as many people into the room as possible. If you can do that before he starts, that would be great.
Could you switch?
There's one particular row, I see 5 seats in the middle, and there's that would be really nice if you could block those up. And there's 4 in the middle here. So, excuse me, can you move that way? Thank you. Thank you very much. Next up, Ray Kinsella presenting TLDK, a TCP/IP stack on top of DPDK and using it.
Can you switch me on?
Can I switch you on?
I hope you can.
It should always be on. It's just mute or no.
I don't think people can hear. Hello? Hello?